This video will discuss rational numbers. Now, a rational number are numbers that can be written as positive or negative fractions, which means that the numerator and denominator can both be written as integers. Now, when we convert them over to decimals, we see that the fraction can either terminate, which means that it has a finite number of non-zero digits. For example, 5/4 when converted becomes 1 and 25 hundredths as a decimal. Or we see that it repeats a digit or a string of digits infinitely. And we can show that repeating pattern by putting a bar over the specific digit or digits. So for example, here we have 5/3. We know that repeats, it's 1 and then the decimal and then 6 is being repeated. So we can write that as 1 and then the 6 with the bar over top. If we did 1/7, we see that we have a repeating pattern of 1, 2, 4, 8, 5, 7. And so we would just write those 6 digits and put the bar over it. Or even something like 37/45, where we have a decimal and then the 8, but what's being repeated is that 2. So we can write the 8 and then the 2 with the bar over top. Now, if we want to convert a terminating decimal to a fraction, the first thing that we would do is determine the place value of our final decimal place. We would write our numerator just as the visible value as if there was no decimal there, and then our denominator would be based on that final place value. And then we'd simplify when possible. So say that we have this value here, and if we say the number as the decimal, that will help us understand what is our denominator. This is 1,234 10,000ths. So that right there should tell us that our denominator should be 10,000. But we can also count our decimal places, and we can go tenths, hundredths, thousandths, 10,000ths, and so that tells us that is the denominator 10,000. Also, look how many times we had to count to get to our final decimal place. That was 4 times, and here we have 4 zeros. So there's a couple ways I can help you know what should the denominator be. So that means we have 1,234 over 10,000, and we do want to simplify that. We know that both those numbers are divisible by 2, so that could become 617 over 5,000. Say here's another example, 2 and 47 hundredths. Well, right there, that should tell us our denominator of hundredths. But again, we can count the decimal places. We see 1, 2. That would tell us we end in the hundredth. Or again, 2 decimal places tells us we need 2 zeros on that denominator. So we write our whole number, which is that entire number, 247 over 100, and that can't be simplified. Now say instead we have a repeating decimal as a fraction. What we first want to do is start with the first number in the repeating string and count how many places it takes to repeat that string of numbers. Our numerator will be the string, and our denominator is going to match the number of places in the repeating string. And we do simplify whenever we can. So let's look at a few examples to help explain what this means. So say we're repeating 13131313 infinitely. We can see that what's being repeated is the 1 and the 3. So that tells us our numerator is 13, and our denominator is the number of digits in that string. Well, there's 2 digits, which means we need 2 nines, or 99. So we'd write that as 13 99ths. Now say that we have this one, we're repeating 3, 4, 5, 6, 3, 4, 5, 6. So we see, well, what's being repeated? It's that 3, the 4, the 5, and the 6. So our numerator is that string, and our denominator is, well, how many digits are in the string? There's 4 digits in the string, so we need 4 nines. In other words, 9,999. That gives us 3,456 over 9,999, which could be simplified. You could divide it by 3 and then 3 again, or you could divide it by 9, but it will simplify to 384 over 1,111. Now, think back to that example we had a minute ago where we had 37/45, where we had the 8 and then the repeating 2. What do we do about trying to convert that into a fraction? So in other words, what if the repeating part's not right after that decimal? What we want to do is actually separate our decimal into the sum of first that non-repeating portion and then the repeating portion. The non-repeating portion we can convert very easily into the fraction like a terminating decimal. The repeating portion we got to pay a little bit more attention to. And what we're going to do is we're going to treat it like it's a repeating decimal, and we're going to multiply it by 1 over 10 to the n. And n is going to be the number of zeros before that repeating decimal. Then we're going to convert it into its fraction, and then we can actually add those two fractions back together. So let's look at an example to help out. Here we have 0, and then we got 15, and then we have this 369 being the repeating part. So the first thing we want to do is split it into the two decimals. So we're going to make that sum. So we have 1500ths, and then we're going to put zeros in the places where the 1500ths were, and we say we got that 369 being repeated. So there's our two decimal values. Now we're going to start by converting the 1500ths. And I just said it as the fraction, so that makes it very easy to help us know how to do it. 1500ths, 15 out of 100. Now I'm not going to simplify it right now. We'll do that at the end after we add the two values together if we need to. So now we need to deal with this repeating decimal. And it's a little bit different because you have those zeros before it now. So the way we do it is it's 1 over 10 to the n, where n is the number of zeros that we see. And we're going to times the repeating decimal. So if we look here, we see 2 zeros, which means that for n we're going to put a 2. So 15 over 100 stays. And then instead of having those 2 zeros, we can say that's 1 over 10 to the second times as the repeating 369, as if it was a standard repeating 369. Now we can convert the 369. We can say, well, that's 3 digits that are repeating, so we need 3 nines. We can multiply and simplify. So if I simplify my fraction here, I can see they're both divisible by 9, or I can divide by 3 and then divide by 3 again. That will simplify to 41 over 111. I follow my order of operations, which tells me to multiply my two fractions first. So that's going to give me 41 over 11,100. And now I need to add my fractions, which means I need a common denominator. And 100 can go into 11,100. Okay, so I can multiply that by the factor that's needed, both the numerator and denominator, and that will give me 1,665 over 11,100. That's the equivalent fraction. And I can add these two values together now and keep my denominator, and I end up with 1,706 over 11,100. And if I divide this in my calculator, I will end up with the same decimal.